this is Dr. K. Raghuram Mohan Reddy, Associate Professor, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. The course name is Unconventional Machining Process. The topic is Definition and Terminology of Module 1 and Part 1. Okay, so here in this presentation, let us discuss half of the definitions and terminology of the Module 1. Basically, that is related to traditional and non-traditional machining processes. Okay, right. At the end of this session, student will be able to understand the definitions and terminology of non-traditional machining. Okay, right. So this is the course learning outcome of the today's topic. Right. Definition of unconventional machining. Okay. So unconventional machining, processes that use non-traditional methods involving forms of energy other than mechanical cutting to remove material. See, usually in mechanical cutting, we need to apply some forces. Okay, cutting forces and physical contact is must. Okay, so here forms of energy other than mechanical cutting. Okay, that is important. This includes mechanical, electrical, thermal and chemical energy. Okay, so here the non-traditional machining process involves mechanical, electrical, thermal and chemical energy. Okay, so only mechanical cutting forces are related to the conventional machining process. Usually in general lathe machine operation or milling machine operation, what we do in order to remove the material, directly we use single point or multi-point cutting tools to cut or machine the workpieces. Okay, so there will be direct physical contact. Either the workpiece may move or the tool may move one against to other in order to remove the material. So some friction will take place, and obviously because of this physical contact and friction, heat may be generating and there will be a great chance of heat affected joint, and subsequently the induced stresses will develop. Okay, right. Traditional versus unconventional. Traditional methods rely on physical cutting tools. That's what we have discussed. Turning, milling are the examples. Okay, while unconventional methods use energy forms such as electrical discharge, lasers, etc. and even chemicals. Okay, right. Historical evolution. Okay, early techniques, manual tools and simple machines used historically. Okay, technological advancements. Innovations in material science and precision engineering led to the development of unconventional methods. See, since 1850, we are using the conventional methods very effectively. During those days, these unconventional machining processes have been evolved but not implemented up to the world's uses. Okay, right. Key terminologies. Machinability, the ease with which a material can be cut, shaped or finished by machining processes. Non-traditional machining, NTM. Okay, non-traditional machining processes that deviate from conventional mechanical cutting utilizing energy forms such as electrical, thermal or chemical. Okay, right. Need for non-traditional machining methods. Limitations of traditional methods. Material hardness. Difficulty machining very hard materials like tungsten carbide or ceramics with conventional methods. Okay, so limitations of traditional methods is that one point is material hardness, second one is complex geometries, third one surface finish. Okay, right. Material hardness, difficulty in machining. Okay, when the material is very hard. Okay, so usually tungsten carbide or ceramics. Okay, it's very difficult by using conventional methods. Okay, the tools may blunt and finally the tools will break if we try to make much force against the tungsten carbide workpieces. Okay, right. Next, complex geometries. Okay, challenges in achieving complex or intricate shapes with traditional cutting tools. Okay, see, usually for the different designs, sometimes complexity of the geometry would be there. So where the non-conventional machining processes cannot be suitable. Okay. Next, surface finish. Okay. So obviously, in aeronautical engineering or some scientific requirements, the surface finish is a predominant factor. Okay. So surface finish limitations would be there in the traditional methods. Okay. So limitations in achieving high quality surface finishes for specific applications, particularly aeronautical and medical applications, and even aerospace, shipbuilding. Okay. So automobile sectors. So in some areas, definitely the surface finish is very much required. Okay. So in optical systems where we use optics, so there particularly in medical field, okay, in surgical items also, so surface finish is very much required. Okay, right. Next, emerging needs. Aerospace industry, that's what we have discussed. Medical devices, already we have discussed. Electronics industry. Okay, right. Let us discuss aerospace industry. High precision required for components like turbine blades, which are made from hard materials. Okay, and medical devices, need for precision and biocompatibility in components such as surgical implants. Okay, so usually in dental and bone total joint replacements. Okay, so in these areas we have to use um, a high strength to low weight ratio materials like titanium. Okay, so these materials cannot be cut very easily by using traditional process. So we have to go with non-conventional or unconventional machining processes. Okay, right. Electronics industry next. Here, when require high precision and fine features. Okay, so there also we have to go with unconventional or unconventional machining process. Next, key terminologies. Okay, so here brittle materials and precision machining. Okay, brittle materials means materials that fracture under stress rather than deforming. Okay, example ceramics, glass. So without any notice, upon applying some load or force, it will fracture. Okay, so without any notice, the material will fail or fracture. Okay, for example, when we apply force on glass, it will not deform. Okay, at some point it will break. Next, precision machining, achieving high accuracy surface finish in the fabrication of components. Okay, right. Classification of modern machining processes: mechanical energy based process, abrasive jet machining, water jet machining, ultrasonic machining. Okay, so abrasive jet machining uses abrasive particles accelerated by gas stream to erode material. Okay, so here we are using abrasive particles with gas stream, that is nothing but abrasive jet machining. Okay, in water jet machining we use high water pressure jets for cutting or cleaning. See, usually we can see in normal areas for any cleaning we are using high pressure water. Okay, even that can be used for the cutting of metals also. Okay, you can imagine how much pressure is required. Okay, ultrasonic machining involves ultrasonic vibrations combined with abrasive slurry to erode material. Okay, so here in ultrasonic machining, abrasive slurry is also part of the machining or removing the material. Okay, along with the ultrasonic vibrations. Right. Electrical energy based processes. Electric discharge machining employs electrical sparks to remove material. Wire uses a continuously fed wire electrode to cut precise shapes. Next, thermal energy based processes. Okay, laser beam machining, electron beam machining, plasma arc machining. Okay, in laser beam machining, focuses laser beams to cut or engrave materials. Okay, right. In electron beam machining, uses focused electron beams for high precision machining. Okay, in plasma arc machining, employs plasma jets to cut or etch materials. Chemical and electrochemical processes. In chemical machining, utilizes chemical reactions to remove material from a workpiece. Okay, in electrochemical machining, relies on electrolytic dissolution for material removal. Okay, right. Key terminologies: energy forms and kerf width. Okay, various types of energy used in machining, including mechanical, electrical, thermal, and chemical. Okay, kerf width, the width of the cut made by a machining process, important for precision and material utilization. Okay, right. So let me reiterate certain points. Okay, so however, students will have to understand where we have to use the unconventional machining processes and where we have to use the conventional machining processes. So obviously, the unconventional machining processes are very expensive, and at the same time material removal rate is somewhat less when compared to unconventional machining process. See, if you take a lathe machine, when the tool strikes the physically the workpiece, rotating workpiece, it removes the material in terms of different thickness of chips. It is not possible with the other machining process, that is unconventional machining process. So here, for just simple step turning or simple turning, we need not go for the unconventional machining processes. Okay, so we can use some CNC machines rather than this traditional machining process. Okay, right. Next one, machinability and non-traditional machining. These two are the key terminologies of the present topic. So machinability is very much important. All materials cannot be machined or finished to the required machining process with the conventional machining process. So sometimes the brittle materials cannot be machined easily. If we try to machine by conventional machining process, what will happen? It will be either subjected to fail or the tool may fail. Okay, the workpiece may fail or the tool may fail. Okay, right. So, but in unconventional machining process, very surgically we can cut the intricate shapes. Okay, but the thing is that it is somewhat expensive. But in a mass production, we will get the benefit. Okay, right. Next, already we have discussed all these things, surface finish and all these things, right? Emerging needs. So, in aerospace industry, medical devices, and electronics industry, we need to have very high precision. Okay, there we have to go with unconventional machining process. We cannot go with conventional machining process. But in order to semi-finish the raw material to semi-finished goods, we have to go with the conventional machining process. And to some extent, we better go with CNC machines. Okay. So for very precision holes over those surfaces which are developed by CNC machines, we can use the unconventional machining process. Very minute holes cannot be made by using the conventional methods. Okay, right. So with this, let me conclude. These are the references associated to this presentation. Okay, thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.